This is problem number 1 on the sample test problems for test number 3. The function f is defined on the interval -2, 4. The graph of its derivative function, f prime, is given below. For each question, give a value or values for x or a range of values for which the given statement is true, or say it cannot be determined from this graph alone. Where is f of x negative? Okay, so first, just to be really clear what this function is, it is f prime. So where is f negative? Well, let's see. F prime gives information about increasing and decreasing, but it doesn't give you any information about where a function is positive or negative. So this problem cannot be determined. Part B, where is f decreasing? Okay, this is information that we can get from f prime. So I'm just going to make a little chart here, and I'll write down some information about about the graph of f. So I'm looking first for the places where f has a horizontal tangent line. So go ahead and mark the points on this graph where f has a horizontal tangent line. Hopefully we see it's at all these x-intercepts. And so then down below, I'm going to go ahead and mark off some information, cutting this graph off at the x-intercepts. And then we're going to figure out what f is doing in between. Not what f prime is doing, but what f is doing. So out here, f prime is what kind of a number? It's negative. And if f prime is negative, what is f doing? F is decreasing. So everywhere out here, f is decreasing. Let's look in the next space. All of this, what kind of numbers are these for f prime? Again, those are negative. So again, what is f doing? F is decreasing. These numbers right here are what kind of numbers for f prime? Those are all positives. So if f prime is positive, what is f doing? F is increasing. And then finally, at the end of this trip, what kind of numbers are those for f prime? Those are negatives. So if f prime is negative, what is f doing? F is decreasing. So I feel like we've got a good handle on the ups and downs for f. So we can now answer question B. It says, where is f decreasing? So we're just going to give the x's here, and we're going to use interval notation. So f is decreasing from the start of this graph, which is at -2, until we get to the first vertical red line there. So f is decreasing from -2 until we get to -1. And then it's going to decrease some more, starting again at -1, and then continuing until we get to about 1. And then finally it decreases some more at the very end, going from roughly 3 until the end of this trip, which I think is 4. That's given in the paragraph at the top. All right, if you choose to include -1, then you could write it maybe as this function is decreasing from -2 all the way until +1. And then again, it's decreasing from 3 out there until 4. Okay, and whether you put parentheses or brackets at the endpoints, it doesn't make any difference to me. So maybe I'll put brackets just so there are brackets everywhere. Either of these answers is fine. Let's move on to part C. Where does f prime have local maxima? All right, f prime is the graph that we are looking at. So the local maxima are the highest points, points that are higher than the points nearby. So I do see a local max up here. That also happens to be the global max. It's the highest point anywhere on this graph. And are there any other local maxes? That is, points that are higher than the points nearby. And there's one more right over here. So here's another local max. It's not the highest point on the graph, but it's higher than the points nearby. So it looks like x equals -1, and maybe x equals 2.4. Part D, where does f have local maxima? Okay, so here we're going to use this nice little chart we built in blue. So we're looking at this line of information right here. So we want to know where f has a local max. So let's look at the information that's given. First, f is decreasing. So I'll go ahead and draw something downward. and then f decreases some more, so it's still downward. Then f is increasing, so I feel like right there at 1 we actually have something. Is that a max or a min? Well, let's see, it went from decreasing to increasing, so that must be a min. And then finally, f is decreasing at the end, so x equals 3 is something, because we went from increasing to decreasing. So x equals 3 is a max. So x equals 3 is our answer. And it's possible that's the only answer, but there are a couple of other points we need to think about. Local maxes could also occur at the endpoints. The endpoints in this case were -2 and 4. So the question is, what is f doing right at the start and right at the end? So f starts at -2. I don't know where the graph is, but I know immediately the graph starts to decrease. So if you have a point and then immediately you start to decrease, would you say that point is a local max or a local min? Feels like that's going to be a local max. So at x equals -2, just by virtue of being a starting point, I'm going to include it as a local max. And then let's look at the other endpoint at x equals 4. So we said this function was decreasing the whole time until we get to 4. So 4 is a point somewhere, I don't know where, and we are decreasing until we get there. So is x equals 4 a local max or local min? Okay, that's a min because it's the lowest point nearby. So that one doesn't count in this answer because we were only looking for local maxes. So I think the only answers we have are 3 and -2. Part E, where does f prime have a global minimum on the interval from -1 to 3? Okay, again, f prime is the graph that we're given. So we're just looking for the absolute lowest point anywhere from -1 to 3. So all in here, we just want the lowest point we can find. And it looks like the lowest point we can find is maybe right around here. So this would be the global min, only on the interval -1 to 3. There are points that are lower on this graph, for example, at x equals -2, but we were only looking between -1 and 3. So for that whole highlighted region, it looks like the lowest point happens at about x equals 0.25. Part F, where does f have a global minimum on the interval -1, 3? Okay, this is going to be a bit trickier. Again, we're focusing on the same yellow highlighted region, but now we're not thinking about the picture we're looking at, we're thinking about f. And so again, we're going to think about this stuff that we've written here in blue. That tells us what f is doing. So only looking at the yellow, let's see, f is decreasing, so we're going down, and then f is increasing. So I feel like decreasing and then increasing right there is a point that is a candidate for a global min. And then I guess we're increasing all the way until the end of this point. We start to decrease after that, but we stop there anyway. So I feel like our answer is right there. It's at x equals 1 because we were decreasing until that point and then increasing after. So we've got our lowest point right there at the bottom. So how can we write that up? So we could say something like at x equals, did we say was it 1? So at x equals 1, since for x a little bit less than 1, f is decreasing. And for x a little bit bigger than 1, f is increasing. Now, it turns out, again, there are a couple of other points that you need to think about when you're asked to find a global min on a closed interval. The other candidates are actually the endpoints, -1 and 3. So let's just pay attention to those just to make sure we didn't miss something. So again, we said that f was decreasing until here and then increasing. So could it be that that -1, the endpoint, is a local minimum? I think the answer is no, because we hit that point and then we start immediately to decrease. And then over here, could this point at the other endpoint be a local minimum? And the answer again is no. It's a maximum actually. So in our case, I think the only answer is the one in the middle, the critical point at x equals 1. Okay, and just to be sure, going to erase these things, and I had said they were, for x a tiny bit bigger than 1 and for x a tiny bit less than 1. So I'm making those intentionally small. There must be some better notation than that, but anyway. Let's move on to G. Where is f double prime of x equal to 0? Okay, let's translate that, because the graph that we're given in this picture is f prime. So instead of f double prime, this translates to where is f prime prime of x equal to 0. So all I've done is separate one of those primes because f prime is the given graph. So this is really just saying, can you take one derivative of the given graph and make it equal to 0? So we do a lot of translating in calculus. There are several layers of translation, and finally we get to a question that's easy to answer based on the picture we have. Where is the first derivative of the given graph equal to 0? So we'll look at the picture we have, ignore the fact that it's called f prime. I'm just going to treat it like its own starting function, and I want the first derivative of the pictured function to be 0. So we're looking for what kind of tangent lines? Horizontal tangent lines. So I feel like we've got a horizontal tangent line there, another horizontal tangent line up there at the top, and that's it. Oh, that's not it. One more horizontal tangent line down there at the bottom. So I feel like we have 3 points where the derivative of this graph, this picture, is equal to 0. So x equals -1, 0.25, and maybe 2.4. So those are our 3 places, approximately, where f double prime is 0.